Okay, taste and smell. Taste and smell. Uh-oh, come on. Alright, so let's start with smelling. Remember the different types of receptors. Smelling is an example of a specialized type of receptor that responds directly to chemicals. In this case, they're called odorants. So chemoreceptors. I always thought this was so weird because it's literally a microscopic, it's actual physical thing that's coming and binding these chemoreceptors in the nasal mucosa. These chemoreceptors, have their little feelers in the nasal mucosa. Then they cross through the epithelial cell and then send these projections up to the olfactory bulb. Remember, this is cranial nerve 1, right? O to touch and feel very good, velvet, heavenly, or whatever mnemonic you want to use. Remember the cranial nerves. There is also a slightly dirtier version of that I won't say. I'll probably get in trouble. Anyway, odorants. Okay, yeah. This always tripped me out because, alright, let's say you take a big crap and it's nasty and you're smelling it. It's literally like tiny microscopic particles of feces that are entering the air, entering your nasal cavity, and binding to these chemoreceptors. It's like a physical thing. That always really grossed me out. And I think about dogs, how dogs have really sensitive sense of smell. They probably just get bombarded with all these odorants. Anyway, people think the reason that walks are so healthy for dogs is not for the exercise, but it's so they can smell new smells. So, what was I talking about? Okay, so eventually you get transduction. This environmental stimulus, this time in the form of an odorant, a chemical, is eventually transformed into an electrical signal in the form of an action potential in the olfactory bulb, and then the olfactory bulb eventually goes to many areas, but these three are the most famous. I don't want to go into detail of this, but smelling, I do want you to be aware of why they go smelling, and you'll see taste is very similar because they're very interconnected, that go to these three areas. So we have to have a conscious perception of smell, frontal cortex, the hypothalamus and the amygdala is motivational and emotional aspects of smell. The hippocampus is odor memory. This is really interesting because things like PTSD victims, for instance, if a woman falls victim of sexual assault, and the classic example is, the man wore a certain perfume or there's a certain smell associated with the memory. If she is exposed to that smell again, years later, she might have a flare-up of her PTSD symptoms or trauma, and because smell is one of the strongest memory hooks and elicitors of memory. That's one reason that divorces and breakups are so hard, is because the smell is still around. The smell of the person is still around for a while, and it reminds you of them. But smell that's why it goes to the hippocampus. Pretty interesting. And that also ties in, the emotional response ties into the amygdala, and also the fight or flight stuff. That's the amygdala and the hypothalamus, because remember, the hypothalamus-spinal tract carries sympathetic modulation for fight or flight and stuff like that. So all these are really kind of interconnected, but just be aware why they go to each area. Anything else I want to say about smell? I think that's it. Taste, very similar. Okay, so remember, olfaction was cranial nerve 1, the olfactory nerve. No, you just got to memorize this. Might ask you a test question on it. 7, 9, and 10. Facial, glossopharyngeal, and vagus. They are all responsible for some taste. The most high yield of all is the facial nerve, because it gives off a branch called the chorda tympani, and the path it takes is actually weird. It travels literally in between the middle ear bones, the ossicles, and then it like comes back out, and then it goes to the tongue randomly, and is actually responsible for the majority of the taste because it's anterior 2/3. So let's put facial, anterior 2/3. That's really high yield. Anterior 2/3 of the tongue. Glossopharyngeal nerve is posterior 1/3. So let's put G for glossopharyngeal. I'll put these as well. By the way, I just realized that I've been naming these videos with Roman numerals, and then in the PowerPoints they have the numbers, and it really bothered me, but then I didn't want to change it halfway through, so I'm just going to keep it consistent. Just let it bother me, I guess. The vagus nerve is responsible for a very small portion of taste, and it's in the back of the throat, the epiglottis. And that makes sense if you think about it, because like 9 and 10 mediate the gag reflex. So that's a nice way to remember it. Gag reflex is all the way back here. 10 is also like swallowing, so that makes sense. The epiglottis needs to move for you need to swallow. Anyway, there are receptors respond to stimulation, and we can only taste like 4, or some say 5 different flavors, and then it's really like the integration of our smells at the same time that allow for like full experience of flavor. Remember, there's like sweet and salty, umami. It's one of my favorite words. And then, some people say there's different areas of the tongue, like bitters in the back and then sweets in the front. I don't know. Don't worry about it. Anyway, these receptors respond to stimulation. I already talked about the cranial nerves that carry the information, the gustatory information. So they synapse in the nucleus solitarius, which does a lot of things. This is just one of them. I think it's also the place where all of your information from, like, for instance, your GI system travels up via the vagus nerve, and then synapses there. I think that's a place, but don't worry. Anyway, then this could technically be called a second order neuron, right? Because there's first order neuron synapse, second order neuron. They cross over and enter the medial lemniscus. Why does that sound familiar? Because that is the exact place that the PCML tracts run. It's in the name, right? Medial lemniscus. Then there's another synapse in the thalamus. Third order neuron sends axons to the gustatory cortex, and that is located in the insula. And the insula is a part of the brain we haven't talked about, but if you kind of like pry open the temporal lobes, the insula is, some people say it's the 5th lobe of the brain, because you have frontal, occipital, temporal, parietal, and then the insula. It's kind of like the 5th lobe. It does a lot of stuff. We don't understand a lot about it. Some people think it houses human consciousness. Anyway, that's about it. Know the cranial nerves and which part of the tongue they are responsible for. Actually, chorda tympani. Yeah, know that chorda tympani. Know that. Okay, maybe might be a test question. Who knows? All right, so I wanted to show you these projections are the exact same. Okay, taste and smell are very sort of similar in that sense. Um, it will send projections, communicate with the sensory and frontal cortex, conscious perception, the amygdala and hypothalamus for emotional quality, like it's just that satisfaction of a nice juicy steak. I don't know, something like that. And the hippocampus, memories. So I got this at this restaurant last time, and it was terrible, right? So that's like pissed off. That's also the amygdala and the hippocampus because you have the memory of that. Or vice versa, have a good memory with this certain food. I think this is where, what's it called, like aversion comes from. For instance, if you're a kid and you eat some peas and you get really sick right after the peas and you throw up all over the place, then you'll kind of always have that negative association with the taste of peas. All right, and you can't stand it because they like mush around in your mouth and you throw up every time it happens and even if the nausea and vomiting wasn't directly related to the peas, you still associate it and then you can't eat peas the rest of your life. That's just a theory I have. It's probably because of this stuff, like the memory and then the negative emotions. Next, we will talk about the BG